Hi guys, welcome back to school, even though you are still at home and I'm at home as well. This is how we're going to be doing our lessons now. Hope your holiday's been really exciting. Been out doing lots of really fun stuff without getting into any contact with anyone though. Yeah, my holiday's been pretty dull, but I'm trying to keep myself entertained. I go for a few walks now and then. So at the end of last term, we started looking at ionic compounds, and here is the lesson for that in Google Classroom if you want to go over it again. And I set you work in the SciPad to do, which I hope you have done. If you still don't have a SciPad, once again, get in contact. I'll try to help you. I did send out a PDF version of one last term as well. Yeah, so what we're going to be doing today is we're going to be looking at molecular substances. If you want to find this slide or any slides that I use, they're down here in the slides folder. Click on that, and molecular substances is what we will be doing today. Check that out. All right. One moment. Alright, so a molecular substance is something made from only non-metal atoms. So here's our periodic table again with the metals in green and the non-metals in yellow. So if it's a substance made up of only of these yellow atoms, these ones here, it is going to be molecular. So, probably heard of water, H2O, made from hydrogen and oxygen. So you can see they are both yellow, so water is a molecule. This is opposed to the ones we were looking at last week, like sodium chloride, which is made from one metal and one non-metal, and that is ionic. But covalent, two non-metals. Atoms in a molecule form bonds, and they are called covalent bonds. And a covalent bond is formed when two atoms share a pair of electrons. So, yeah, let's have a look what that means. So, you may remember from last year, atoms want to have a full valence shell, or that's the outermost electron shell. Most atoms want to have 8 in their outer shell, except for hydrogen, which just wants 2 in its outer shell. So, simple rule for this, all atoms want 8 except for hydrogen, that just needs 2. So here we have three different molecules. This one is 1 carbon with 4 hydrogens, CH4, what's sometimes called methane. And here you will know that carbon has a electron configuration of 2 in its first shell and then 4 in its outer shell. And for this diagram, they're only showing the 4 in the outer shell, which are these 4 blue ones. And hydrogen, you know, just has one electron each in its shell. Now here we have 4 bonds. 1 bond between the CH here, 1 bond here, 1 bond here, and 1 bond here. Each hydrogen has 2 electrons, 1 of its own electron and 1 from carbon. And the carbon has 8 electrons, 4 from itself and then 1 that it shares from each hydrogen. So in this molecule, the hydrogens and the carbons have a full outer shell. Here we have 2 hydrogens bonded together. These are both electrons, one's an X and one's an O, just to show you that they're from each hydrogen, they're from different hydrogens. But here we've got a covalent bond where they're sharing these 2 electrons, so they both have 2 electrons in their outer shells. Here's the last one, chlorine. In its outer shell, it's got 7 electrons. 1, 2, 3, 4, 5, 6, 7. It needs one more, so the hydrogen will share one of his with the chlorine, and the chlorine will share one of theirs with the hydrogen. So what we're going to be doing is we're going to be working out how to draw these diagrams, and we're going to start off with drawing these things called Lewis structures, or Lewis diagrams. So a Lewis diagram is used to show the arrangements of valence electrons, or they're the electrons in the outermost shell. These are the only ones which are going to be involved with bonding, so they're the only ones we actually care about for this. So how to do it is very simple. Write out electron configuration and determine number of valence electrons. So oxygen has 8 electrons. We can see that because it's got an atomic number of 8, and 2 in the first shell and 6 in the second shell. Remember, when you fill up the shells, it goes 2, 8, 8. Yeah. So 6 in this valence shell, so it's got 6 electrons around it. And we start placing the valence electrons around the atom in the order from up, right, down, left. Where it says 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. So we put the first 4 there, and then we've got 2 more, and those 2 more, they start doubling up. So we put another one here, and another one here. So here we've got our 6 electrons around the oxygen. 2 of them are in a pair, we call these lone pairs, and 2 of them are single electrons. These single electrons will be able to form covalent bonds. Yeah, let me do another one on this piece of paper here, which I found. So let's choose another element. I'm going to go with sodium. Sodium has an atomic number of 11. Sorry, go back. Atomic number of 11 and a mass number of 23. Just got to check down that periodic table. So, where are we? 11 and 23. How many electrons has it got? Look at the mass number, the atomic number. It's got 11 electrons. That's my working. It's real good. 11 electrons. And what's the orbital going to look like? Now, what's the electron shell going to be? We've got 2 in our first electron shell, always. 8 in our second. So 2 and 8 is 10. Then we've only got 1 left over. So that's going to go into our third electron orbital. So the electron arrangement is going to be 2, 8, 1. 2, 8, 1. How many valence electrons do we have? That's the outermost one. 1, just 1 valence electron. So to draw the Lewis structure for that, we just write Na, and then we start putting the valence electrons there, starting at 12, and that's all, because there's only 1 valence electron. So to draw that diagram, it's just the Na with a dot above it. They had 2 electrons, we'll start putting the next one there and go round. That's very simple, eh? Right. So there's some questions in the SciPad about that. You can probably breeze through that really quickly. I'm going to talk about this briefly, and yeah. So drawing Lewis diagrams of molecules. So a molecule is going to be made up of more than 1 atom, obviously, and we can get these Lewis diagrams of atoms and work out how they will fit together into a molecule. So here I have my 3 Lewis diagrams, and you can see with chlorine it's got 1 unpaired electron here, nitrogen has 3 unpaired electrons, and oxygen has 2 unpaired electrons. What these unpaired electrons want is they want to get another electron and form a bond. So it'll have a full outer shell. So chlorine just needs to bond with one thing to get its 8 electrons. Nitrogen is going to have to bond with 3 things to get its 8 electrons. Oxygen is going to need to bond to 2 things. So here it says chlorine has 3 lone pairs and 1 unpaired electron, so it will form 1 bond and 1 bond only ever. Chlorine only ever forms 1 bond. Nitrogen has 1 lone pair and 3 unpaired electrons, so it will form 3 bonds always. And oxygen has 2 lone pairs and 2 unpaired electrons, so it will form 2 bonds. So here's a very, very simple one. Hydrogen and chlorine. You can see hydrogen has 1 unpaired electron, chlorine's got 1 unpaired electron. They need 1 electron each, so they join together and form this covalent bond. So this line here, this dash, that represents a bond. But what you need to remember in molecules is that bond also represents 2 electrons. This electron here and this electron here are now in this bond. So chlorine has 1, 2, 3, 4, 5, 6, 7, 8 electrons around it, 2 on the bond, and hydrogen just has 2 electrons. So they're both happy, they've both got full outer shells. There we go. Both hydrogen and chlorine have 1 unpaired electron. These electrons form a covalent bond. The line represents a covalent bond and consists of 2 electrons shared between the 2 atoms. There's something else to look at. I basically said it in the last page. So let's have a look at some examples of how you could draw one. So if you drew the structure for oxygen, which we did before, here we can see it has 2 bonds, or 2 lone electrons, so it's going to form 2 bonds. While chlorine just has 1 unpaired electron, so it's just going to form 1 bond. So your question may say, draw the Lewis structure for OCl2. That's 1 oxygen and 2 chlorines. We know that oxygen forms 2 bonds, as I said before, and chlorine will form 1 bond. Okay, so how is it going to be arranged? If you have only one of an atom, we only have 1 oxygen, then it's probably going to go in the middle. So we're going to put that one in the middle. And it's going to be bonded to the 2 chlorines beside it. So as you can see, I have my oxygen in the middle. My oxygen before had 2 lone pairs and 2 single electrons. Now these, each 1 lone electron from chlorine is going to bond with 1 of the lone electrons in oxygen to form this bond here. And there's going to be the same on the other side. So oxygen is going to bond, it's going to share 1 electron with each chlorine. If we draw circles around it, once again we can see that each atom here has a full outer shell. As you can see, these dashes here, the bonds, are encompassed in 2 circles. Those are 2 electrons which are being shared. So this chlorine, 1, 2, 3, 4, 5, 6, 7, 8 electrons. This oxygen, 1, 2, 3, 4, 5, 6, 7, 8 electrons. And chlorine, also 8 electrons. Yeah, so that's a simple way how to draw them. Here's a little cheat sheet on how to remember how many bonds they form and how many lone pairs they have. So we'll start from the left. Hydrogen only has 1 electron, it wants 2 electrons, so it is just going to form 1 bond. It hasn't got any lone pairs. So hydrogen always forms always makes 1 bond. We're going to move across to group 17 now. Group 17, fluorine, chlorine, bromine and iodine, they all have 7 electrons in their outer shell. They only need 1 more. because they only need one more electron, they are only going to form one bond. Because I've got 7, that means they're going to have 3 lone pairs. That's when they're 2 dots next to each other, or 2 electrons paired together, and 1 free electron for bonding. So it forms one bond. Oxygen, sulfur, selenium, and whatever that one is. I'll look it up later. These are all in group 16, and they form 2 bonds. So they're going to have 6 electrons around them. 2 of them are going to be paired up into lone pairs, and 2 of the electrons are going to be free electrons available to make bonds. So yeah, they're going to form 2 bonds and have 2 lone pairs. Nitrogen, phosphorus, and astatine, or something like that. They form 3 bonds. They've got 5 electrons in their outer shell. They want 3 more electrons, so they want 3 more electrons, so they're going to form 3 bonds to get them, and they'll have 1 lone pair of electrons. Carbon and silicon, they don't have any lone pairs, they just have 4 electrons, 4 free electrons around them, so they're going to form 4 bonds, get 4 more electrons, and have a full outer shell. Boron, for B, is a bit different and does something weird. It's an exception, and we will be looking at that later. Alright, I'm going to leave that. That's all I'm going to teach you today, but now I'm going to just give you some instructions on what I want you to do. So could you please do page 40? Oh, no, I'm giving you the answers. Go away. Alright, don't look at the answers. Page 40. And page, go away. 40, 41, 42, and 43. Yeah. So, 40 to 43. And, yep, so do those first. And then I have set you some work on Education Perfect. It's not much at all. Ionic substances, which we looked at last term, and introduction to bonding. So I want you to do these as quickly as possible. I'm going to confirm selection now, and I expect you to do them by Friday. So when Friday, yeah, that one there. Give you a few more hours. Friday, 3 o'clock. You should be able to finish that by. Is that right? And just to make sure that you realise the importance of homework, which some people may think, hey, I don't need to do this, it's homework, no one's going to check on me. I do get updates who completes the work on Education Perfect, and last year I did a little inquiry into my teaching to see how doing work on Education Perfect, how much work you can complete, how that translates to your grades in the end of year. So I made this spreadsheet. You can see it, it's not awesome. And I had 17 kids in my class last year. I haven't got their names up because it's for their privacy. And I set them 1, 2, 3, 4, 5 weeks of homework and recorded who did the most. Or how much they did, sorry. So here I've ordered them from who did 100% down to some guy who did 5%. So these people at the top did the most, these people at the bottom did the least. If we come over and look at the grades, we can see the blues and greens for excellence and merits are generally at the top for people that do more homework, and the reds and the not achieved or did not sits are down the bottom for the people that didn't do as much homework. So we've got the end of topic test, the school exam, and the NCEA exam. As you can see, one guy ruined my results by getting the excellence in the NCEA exam and only doing 6% homework, or 8%, but trust me, on average, the people that do more homework will achieve better, surprising that. Yeah, so I'm going to leave it at that. hopefully I will try organise a lesson sometime, like a Google Meetup or something. Maybe on Friday. I'll send another lesson out tomorrow. And yeah, we can have a chat and see how everything's going. So let's leave it at that, and I'll see you tomorrow with another lesson.